We are covering descriptive statistics for the Fundamentals of Engineering exam, a topic found in the Engineering Probability and Statistics section of your NCEES FE Reference Handbook. This is a critical area because these concepts are guaranteed to appear, either as direct questions or as necessary steps in more complex problems. Let's start with the measures of central tendency: mean, median, and mode. The mean is simply the arithmetic average. The median is the middle value when the data is sorted. The mode is the value that appears most frequently. A common FE exam question involves a skewed dataset and asks for the best measure of central tendency. For instance, consider a set of concrete strength tests in PSI 3000, 3100, 3050, 3200, and 5000. The mean is pulled higher by the 5000 psi outlier, resulting in 3470 psi. However, the median, the middle value of the sorted set, is 3100 psi. The exam will test your understanding that for skewed data, the median is often a more representative measure of the typical value because it is less affected by extreme outliers. Next, let's discuss variance and standard deviation, which measure the spread or dispersion of data. A key exam trap lies in the formulas found in the handbook. You will see a formula for population variance, which has a denominator of n, and a formula for sample variance with a denominator of n-1. The FE exam almost exclusively deals with a sample of data taken from a larger population, so you must use the n-1 formula. Forgetting this is a frequent cause of incorrect answers. The standard deviation is simply the square root of the variance, which conveniently returns the unit of measurement to its original form, like psi, instead of psi squared. A memorable phrase to keep this straight is sample starts with s, so subtract 1. When you are dealing with a sample, you subtract 1 in the denominator for the variance calculation. Finally, we have confidence intervals. These provide a range within which the true population mean is likely to fall, based on your sample data. The exam will typically give you a sample mean, a standard deviation, a sample size, and a confidence level like 95%, and ask for the interval. The biggest confusion point is whether to use the z-statistic or the t-statistic. Use the z-statistic when the population standard deviation is known or when the sample size is large, generally considered more than 30. For a 95% confidence interval with a large sample, the z-value is 1.96, a number worth remembering. If the population standard deviation is unknown and the sample size is small, less than 30, you must use the t-statistic, which requires finding a value from the t-distribution table in your handbook using degrees of freedom, which is n-1. For example, if you test 50 soil samples and find a mean moisture content of 22% with a sample standard deviation of 3%, you would calculate the 95% confidence interval using the z-statistic because n is greater than 30. The calculation would be 22% plus or minus 1.96 times 3% divided by the square root of 50. Mastering this decision process is critical for exam day success. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.